Hello everyone, we are Energy Group 3 and today I will present about our power plant design. First, we have the power plant constraint, which is power plant requirement that we have to generate 5.5 megawatt of electricity. And we have generated information, which is efficiency of it is 98%. And the steam turbine information that we have is isentropic efficiency 74.8%. And the high pressure inlet is 44 bar G, which is around 45 bar, and the temperature is 485 Celsius. And we have three options of fuel option. It's a wood chip that have 40% of moisture, sugarcane leaf that have 25% of moisture, rice husk that have 6.5% of moisture. And from this constraint, we will use the biomass fire regenerative reheat Rankine cycle for our power plant design. And next, we need to use the delta T optimum technique to find the pressure line for our TS diagram, then use that pressure to find entropy in each stage. Also, we need to consider the isentropic efficiency from the constraint in the entropy calculation. After that, we can find the cycle efficiency, which is around 32.5%. And for the overall efficiency of the power plant is around 25.5%. For the rice husk fuel, which is the best option for the fuel because it has the lowest moistures. And next, for the hour operation, we will burn the fuel to heat up the water in the boiler to steam at pressure 45 bar and send the steam to a high pressure turbine to get work that run the generator. When the steam is out of the high pressure turbine, it will go back to the boiler again to reheat at pressure 10 bar, then send the reheat steam to the low pressure turbine to operate again. After that, the steam will go to the condenser for the condensation process at pressure 0.1 bar, which we use a cooling tower to cool the hot steam down because from the TS diagram. In this state, the steam is in the superheat state. Then we use a pump to send the water to the feed water heater. Now the water is heated up by the hot steam that is leaving from the low pressure turbine at pressure 1.78 bar. And lastly, we use a pump to increase the pressure back to 45 bar and send the water back to the boiler. And now, the cycle is complete. And the next step, my friend will tell you about each component.
For the steam turbine, we trying to find an industrial turbine that aligns with our calculated spec for the steam turbine, fuel consumption, and energy output, which means we came up with MAN MST040. We have the spec high pressure output range from 3000 Pascal to 15,000 Pascal, with energy output range from 4 MW up to 20 MW, with a pressure bars of 140, max inlet temperature of 540 Celsius, with a sharp speed from 4,300 up to 15,000 revolutions per minute. For power generation set, we will buy from MAN's energy as a whole, so they compatible with each other. The first component is the main turbine unit or MST040, which had a range pipe from 50 million baht up to 200 million baht. For our spec, we got estimate cost around 93 million baht, and the same for generation unit with estimated cost of 30 million baht. Auxiliary system and controls around 18 million baht, and for the installation cost, civil works and foundation 8 million baht, mechanical installation, piping and electrical 8 million baht, commissioning and testing 4 million baht, and import logistics for 1 million baht, with a total cost of 174 million baht.
Next, let's look at the boiler. Since we are burning rice husk, which can be tricky to handle, we can't just buy a standard off-the-shelf boiler. We need a special setup called biomass water tube boiler, which use a fluidized base furnace to burn the food smoothly. Look at the top of the slide. Here is our main spec. Our boiler makes 20 tons of steam per hour. We add a little extra capacity just to be safe during the busy time. The pressure is set to 55 bar G, which gives us plenty of room to operate safely. To make our pan more efficiency, we add the reheat section. This takes steam that has already done some work, heat it up back to 485 Celsius and send back to make more power. We also have an economizer. Think of it as a reheat recycler. It uses leftover hot exhaust gas to warm up the water from 160 degrees to 210 before it even enters the main boiler. Finally, feeding dry rice husk into the fire is risky because the fire can travel back to the fuel pipe. To stop it, our fuel feed needs to use a rotary airlock. It acts like a revolving door, letting fuel in but keeping the fire out. Now let's talk about cost, which you can see the bottom half of the slide in Thai baht. The most expensive part is a coal boiler, costing between 38.5 to 80.4 billion baht. It costs this much because we need really strong, expensive metal to handle the extreme of 485 Celsius heat and the rough, sandy ash that comes from the burning rice husk. On top of that, we have to pay a rust storage bin and conveyor to handle the fuel, filter to catch the ash and keep the air clean, extra pump, fan, and control system, and of course, the construction to build and test the whole thing. When you add it up with total estimate cost to build this boiler system will be between 112.5 million to 209 million baht.
Condenser. We use a shell and tube water cooled condensers. It's used for steam turbine pan up to 50 megawatt. The tube range is 5 to 14 meter. The surface area is 1,000 to the 6,000 meter. The cost is around 10.8 million baht up to 32.4 million baht, depending on the material and the surface area. This condenser input with 45.8 degrees Celsius stream and changing its phase into the liquid. For cooling towers, we use induced draft counterflow. The capacity is about 70 kilowatt cooling. The fan motor is 0.75 to 1.1 kilowatt and the height is 2 to 2.5 meter. The flow rate is 4.7115. The feed water heaters to maximum our efficiency. We use the feed water heaters to use the 1.78 bar extract steam to heat the water up to 116 degrees Celsius. Depending on our quality and purity of the waters we use, but usually the price for the water is around 15 to 30 baht per liter. Flow rate is 0.5685 kilowatt per second. We input the water from pump at 45 degrees Celsius mixed with the steam from the low pressure steam turbine at 116, and then the output is the water at the 116 degrees Celsius at 1.78 bar. We use boiler feed tank with diureser. It remove dissolved oxygen and heat feed water before enter the boiler. The typical operating condition, the stream pressure from 1 to 10 bar and the feed water temperature is 110 to 170 degrees Celsius. The price starting at 158k to 9.5 million baht.
As for feed water pump, we planning on use two kinds of feed water pump. The first is our main pump, which is boiler feed water pump, and the second one is our boiler feed water pump. It's a multi-stage centrifugal pump, which has a maximum flow rate of 1,500 cubic meter per hour and maximum head of 1,000. maximum working pressure of 100 bar. Parameter inlet mass flow rate of 21 ton per hour. Inlet pressure of 1.78 bar. For condensate pump type is multi-stage centrifugal pump. Installation in vertical inline. Maximum mass flow rate of 192 cubic meter per hour. Maximum height of 415 meters. Maximum working pressure of 40 bar. Parameter inlet mass flow rate of 18.7 ton per hour. Inlet pressure of 0.1 bar. Design note: each of these pumps costs us around 1.2 to 3.2 million Thai baht per pump. For condensate pump, we use head around 17 meters from condenser to feed water heaters. For boiler feed water pump, we use head around 440 meters from heaters to boiler. Next, for calorific values. Wood chip at 40% moisture content has calorific value of 9.72 megajoule per kilogram. For sugarcane of moisture content 25% has a 14 megajoule per kilogram. Lastly, for our rye husk at moisture content of 6.5% has a calorific value of 14.2 megajoule per kilogram. In this plan, we plan to use only rye husk and sugarcane because wood chips give us much lower calorific value than other tools.
Annual supply and distribution. By the contract, we need to produce energy roughly at 11 million kilowatt hours per quarter. For the first quarter, our main fuel is sugarcane leaves. Why? The reason that we use sugarcane leaves as the main fuel for the first quarter is in the first quarter of the year, there are sugarcane harvesting season, so we got a cheaper price for sugarcane leaves. Also, there are no or very less light husks at the time. For the fuel price, we got around 890 baht per ton with the price difference from Midpon Group that they bought for 890 baht per ton. So to produce 11 million kilowatt hours per quarter, we need a roughly 14,800 tons per quarter of sugarcane leaves with a logistic cost of 300 baht per ton. So it came out with 17,600,000 baht for the first quarter. For the second quarter, our main fuel is light husk. Why light husk? Because in the second quarter of Thailand, there are light harvesting season, so there are a lot of light husk laying around. So we buy a light husk for 800 baht per ton from the reference price by the light hull construction that they bought for 700 to 900 baht. So we roughly round out at 800 baht per ton with a logistic cost of 200 baht per ton, with a quarterly cost in total of 11,700,000 baht, and it goes the same for the rest of the quarters. But for the third quarter, we could not just simply go buy the light husk at 800 baht per ton, so because it's out of season, so we're thinking of an idea that we're building a shed to keep the light husk at the second quarter to use in the third quarter too. And here the calculation, the 6,500 square meters high clearance biomass shed will cost around 38 million baht, including the land price. And here the reference point of buying husk or storing husk, it cost effective more. So Q2 purchase plus storage cost will take around 1,100 baht per ton. If we're gonna buy the light husk at the quarter 3, it will take around 1,650 baht per ton. So it's saving around 550 baht per ton. So the annual total saving will be roughly at 7,920,000 baht per year, and the payback period will be around 4.8 years, and after that will be a pure profit. If we just buy the wood chip at the quarter 3, wood chip is all year round available, so there are no price tag. The cost of energy from store husk 1,100 baht, and the cost of energy from Q3 wood chip, it will take 1,900 baht to make the same amount of energy. So the saving per unit of energy is 800 baht, and the payback will take around 4 years. And here come for the total cost. At first, the initial cost, power generation set at 174 million baht, boiler for 161 million baht, feed water pump and heaters 16 million baht, cooling tower 145 million baht, condenser 22 million baht, biomass shed 38 million baht, powerhouse structure 20 million baht, and initial total cost at 576 million baht. And the yearly cost for the power plant, the salary for engineers and workers will be come up at a total of 18 million baht per year. Fuel and logistics 56.12 million baht, and the maintenance cost for the power plant, power generation set come at 2 million baht per year, boiler also 2 million baht, pump and feed water 500,000 baht, building 500,000 baht. So the total cost for yearly cost is at 80 million baht. For the gross revenue, our 5.5 megawatt MANS MST040 turbine can generate approximately 44.325 million units of energy per year. The estimate assumes that an industrial available factor of 92%, which accounts for standard downtime for maintenance and inspection. Annual production calculation will be at hourly output of 5,500 kilowatt hours at full contact load, of course, and annual operating hours will be at 8,060 hours, 92% of the whole year. So the total annual unit will be at 44.3 million kilowatt hours. Revenue generation at the typical industrial feed-in tariff or FIT for biomass power plant is at 4.2 to 4.85 baht per unit. We assume that we sell for 4.5 baht in our contract. This turbine could generate roughly 200 million baht in gross revenue annually with ROI of 4 years and 10 months, and after that it will be a pure profit. And the reference for FIT price came from Energy Regulation Commission of Thailand. Thank you.